Hello, pre-algebra students. We're going to be looking at a focus on operations section of this chapter, and it's called Performing Operations on Square Roots. I want to show you how you can use product and quotient properties of square roots and the distributive property to perform operations on square roots so you're ready to do the rest of this chapter. Let's begin by multiplying and dividing radical expressions. In the first example, we're multiplying the square root of 15 by the square root of 6. So our first step is to use the product property of square roots to rewrite this as the square root of 15 times 6. Then we can multiply, which gives us the square root of 90. We can use the product property of square roots to make this the square root of 9 times the square root of 10. The square root of 9 is 3, and since the square root of 10, since 10 is not a perfect square, we simply leave this as the square root of 10, giving us the answer of 3 times the square root of 10. Let's try another example. Our next example is to divide the square root of 20 by the square root of 15. We can use the quotient property of square roots to simply rewrite this as the square root of 20 over 15. Just put the fraction under the radical. We can simplify that since 20 and 15 share a factor of 5 to the square root of 4 over 3. Now we can use the quotient property of square roots to redivide that, or re-separate that, into the square root of 4 over the square root of 3. Okay? Now we know that the square root of 4 is 2. 3 is not a perfect square, so we keep our radical sign and keep it the square root of 3. We cannot have a square root in our denominator, so to get rid of that, we're going to multiply both the numerator and the denominator by the square root of 3. Because multiplying by the square root of 3 over the square root of 3 is basically the same as multiplying by 1. That gives us 2 times the square root of 3 over 3, since the square root of 3 times the square root of 3 would be 3. That process we just did, where we multiplied both the numerator and the denominator by the square root of 3, is called rationalizing the denominator. We can't have that square root sign underneath, in the denominator. That simply isn't correct. So we multiply through, and we have a final answer of 2 times the square root of 3 over 3. Now we're going to try adding and subtracting radical expressions. This first expression is 2 times the square root of 5 minus the square root of 7 plus 6 times the square root of 5. The first thing we'll do is use the commutative property. Remember, that means that it doesn't matter in which order we add and subtract. We should get the same results. So we can rearrange this to put our square roots of 5 together so that we have like terms together. Okay. Next, we're going to use the distributive property. You'll notice that we have square root of 5 and square root of 5 here, so we can actually factor this part of the expression. And we can have the square root of 5 times 2 plus 6 minus the square root of 7. Now, usually you're going to have your whole number ahead of your radical sign, so we would actually want to write this like this. I just know that you've learned to factor by putting your common factor in front. So I wanted to show you that, and now I'll show you that this is the correct way to write it. So our next step would be to add 2 plus 6, giving us 8, times the square root of 5, minus the square root of 7. So this is your final correct answer. 8 times the square root of 5, minus the square root of 7. In our next example, we'll be calculating 4 times the square root of 2 minus the square root of 18. So the first thing we'll do is factor using a perfect square factor. So we'll keep 4 times the square root of 2. Now we're going to factor the square root of 18. Our perfect square factor is 9 times 2. Now we can use the product property of square roots. We can have 4 times the square root of 2 times the square root of 9 times the square root of 2. These always get a little messier before you can start cleaning them up and get to your final answer. Now we have 4 times the square root of 2 times 3 times the square root of 2. Now we use our distributive property, which is to pull out that square root of 2 as our common factor, and 4 minus 3 will go in our parentheses. So our final answer is actually just the square root of 2, because 4 minus 3 is 1. The 1 is here, but we don't have to write it. It's just invisible and implied. So the final answer here is the square root of 2. In our last problem in this bonus section, we're going to look at using a radical expression to solve a real-world problem. So let's imagine that we are dropping an object. The expression, the square root of h over 16, gives us the time in seconds that it takes an object dropped from a height, which equals h, to reach the ground. So this full formula here gives us the time in seconds that it takes our object to drop h feet. So about how much longer does it take an object dropped from 128 feet to reach the ground than it would for an object dropped from 32 feet? Okay, so the first thing we'll need to do is find the time when h equals 128. So that's number 1. Let's go ahead and do that. So we have the square root of 128 over 16. So what do you think is the first step we want to take here? We just simply want to divide 128 by 16 and hope that we get a whole number. And we do. We get 8. So the square root of 8 is the answer to that step. Now we're going to use the product property of square roots to factor using the perfect square. So the largest perfect square that is a factor of 8 is 4. So this will become the square root of 4 times 2. Okay. Now we use the product property, and we have the square root of 4 times the square root of 2. The square root of 4 is 2. It's giving us 2 times the square root of 2 as our answer for number 1. So when the height is 128 feet, it will take 2 times the square root of 2 seconds for that object to hit the ground. Now let's calculate our time when the object drops 32 feet. So once again, our time is calculated by h over 16, the square root of h over 16. And in this case, part 2, h is going to equal 32. So we have 32 over 16. So 32 over 16 is going to give us the square root of 2, because we divide 32 by 16 to get 2, and that stays under that radical sign, so we have the square root of 2. And that's it. The answer is simply the square root of 2. Now, the question was to find the difference between the times. So our final step, step 3, is to take 2 times the square root of 2 and subtract the square root of 2. So we'll need to use the distributive property to do that. So we'll have 2 minus 1 times the square root of 2, which gives us an answer of the square root of 2. So the final answer to our question about how much longer does it take an object dropped from 128 feet to hit the ground than an object dropped from 32 feet is the square root of 2. And if you wish to calculate that on your calculator by simply putting in second square root 2, you would get an answer of approximately 1.4. So it takes about 1.4 seconds longer for an object dropped from a height of 128 feet to hit the ground than an object dropped from the height of 32 feet. Okay, that brings us to the end of this focus on operations. I will see you tomorrow to do some practice with this.